You open your phone, type in an address, and within seconds you have a perfect route with live traffic. But have you ever stopped to wonder, Flunder, how does it actually do that? What is happening behind the scenes? Today, we're pulling back the curtain on one of the most impressive technologies most people use every single day. This is Google Maps, and the engineering behind it is far more fascinating than most people realize.
It all starts with data, meta, and we're talking an almost incomprehensible amount of it. Google has spent over 2 decades building a digital copy of the entire world.
They did it using Street View cars, vehicles with giant 360-degree camera rigs mounted on the roof. These cars have driven over 10 million miles across more than 100 countries. As they drive, the cameras emit scan lines in every direction in FLOMID, capturing everything around them.
Every road, building, and street sign is captured and converted into structured map data.
But Street View cars can't go everywhere to SI, so Google also uses satellites orbiting overhead. Satellites and aerial planes photograph the Earth from above, capturing that bird's-eye view you see when you zoom out. These images are stitched together from multiple passes, different times of day, and different seasons. And Google constantly refreshes these images. Some high-priority areas are updated every few weeks. Collecting images is just step 1. Those images have to be turned into an actual usable map. This is where Google's machine learning AI comes in, scanning every image automatically. The AI identifies roads, intersections, speed limit signs, crosswalks, and lane markings. One-way streets, turn restrictions, road closures, all detected and recorded automatically. What would take humans centuries to do manually, Google's AI processes in a fraction of the time. And the system never stops learning. Every correction and update makes the model smarter. Okay, the map is built. But what about live traffic? How does Google know there's a jam right now?
The answer is simple. Tate, it's you. And every other person using Google Maps right now.
Every phone running Google Maps with location on is anonymously sending speed data back to Google. If 1,000 phones on a highway slow from 65 miles per hour to 520, Google knows there's a jam.
The map updates in real-time to Tate, and your route gets recalculated before you even reach the problem.
You're not just a user of Google Maps, Tate. You're a sensor in a massive citywide data network. Now here's where the real magic happens: routing. When you enter a destination, Google doesn't just find a path. It finds the best path using a mathematical formula called Dijkstra's algorithm. The algorithm calculates the shortest route across hundreds of thousands of connected road segments. But Google layers in real-time traffic, speed limits, road closures, and turn restrictions on top of that. It even predicts future traffic based on historical patterns, knowing rush hour will hit before it does. All of that calculation, and millions of variables married, completed in under 1 second. Beyond routing, Google Maps has features most people overlook, starting with Street View. Street View lets you virtually stand on almost any street corner on Earth, using stitched 360-degree photos. Google has even mapped the inside of airports, malls, and stadiums with indoor maps. Floor plans and interior photography let you navigate inside buildings just like you would outside. So the next time you tap Google Maps to find the nearest coffee shop, think about what just happened. In that one-tap CRAV, satellite imagery, AI-trained maps and crowdsourced traffic data, all activated. A routing algorithm calculated millions of possibilities and handed you the best one. All of it saned in under a second. That's the kind of engineering quietly powering our everyday lives. If you found that interesting, hit subscribe, boys. The How Lab breaks down exactly how everyday technology works.
New video every week. See you in the next one.